So let's start with the 11th question, and it is said here, find the center of mass of a uniform plate having semicircular inner and outer radii R1 and R2. Okay, so it's a plate that is a flat surface. So let the mass density be sigma kg per meter square be the mass of this particular plate. And due to the symmetry of this diagram, we can say that its center of mass will be lying on the y-axis. From the center, this is y-axis and this will be x-axis. By symmetry of the diagram, I can say that by symmetry of plate, its center of mass will lie on y-axis. Now let us consider at a distance y a small elemental area or elemental ring of thickness dy of this plate. So here this is the small elemental ring of thickness dy. So the elemental area will be pi y dy, that is semicircle circumference into thickness. So the mass of that element will be sigma into dA. So it will be sigma into pi y dy dm. Now the y coordinate of center of mass will be equal to integration y into dm upon integration dm. Now the y coordinate of center of mass will be equal to, first of all, here y stands for the center of mass of the element. As element itself is a ring, so its center of mass will be what? That we have to find. So center of mass of an arc, we know that the center of mass of an arc is r sine theta by 2 upon theta by 2, as this is a semicircular ring, elemental ring. So it will be the radius which is assumed to be y into sine pi upon 2 divided by pi upon 2. So sine pi by 2 will be 1, so it will be 2y upon pi. So that would be, so here the center of mass of this elemental ring will be 2y upon pi into dm is sigma pi y into dy divided by integration sigma pi y into dy. The limit y varies from inner radius to outer radius, that is from r1 to r2. Sigma, sigma, pi, pi are constant and they get cancelled out by taking them as out from outside, while 2 upon pi will remain as it is. Y into y become y square into dy upon integration y dy. Limit varies from r1 to r2. Now let's take the next page. So the y coordinate of the center of mass of the semicircular plate will be 2 upon pi. Integration of y square will be y cube by 3. Limit varies from r1 to r2, and integration of y will be equal to y square upon 2. Limit varies from r1 to r2. So the y coordinate of center of mass will be equal to 2 upon pi in bracket r2 cube upon 3 minus r1 cube upon 3 divided by r2 square upon 2 minus r1 square upon 2. Now I can take this 3 as common. r2 cube minus r1 cube upon r2 square minus r1 square by 2. So this 2 and this 2 become 4. 4 upon 3 pi in bracket r2 cube minus r1 cube upon r2 square minus r1 square. And this can be reduced further, but you can keep this as it is also. So that would be the center of mass, and reducing further this algebraic expression by using a cube minus b cube property, you can also reduce it. Thank you.